So we've had a busy day today, and we've got a couple of really interesting speakers that we're going to be going over a couple of sort of finer points of some of this notion of information-driven production and Internet of Things. So I think it's going to be good. And before those fine speakers, we're going to start with me. Just talk a little bit more about this whole notion of information-driven production and what I call smart manufacturing in action. So this is a quote I come across from time to time, and I like it a lot, particularly in this context, from William Gibson, who's a science fiction author. The future is already here, it's just not very evenly distributed. Well, I see that every day, day in and day out. I mean, I see it with my kids and some of the folks they interact with, and I see it when I go in one manufacturing plant and they're trying to just manage everything with paper and pencil and maybe spreadsheets, and the next one they're doing every high-tech thing you can think of. And I think that's a good example of this. Future is almost here, is here, and it's not here yet. So when we start talking about this notion of information-driven manufacturing last year, and the notion is to employ some information-driven value networks and business processes and decision-making in order to support some big changes in your organization. So innovations in products and processes and systems and business models, global growth initiatives, things like energy management, or really fundamentally changing from providing products to customers to providing services that take the form of a physical thing. So those are the kind of things that we're seeing, and we're seeing even more of that talk as we go forward this year. When we started thinking about some of the ways things could be information-driven, we came up with quite a big list, and sort of on the left here, I won't go through this chart, but on the left here is a list of some of the technologies that people are finding clever ways to use. And then I just broke it down into the three categories I talked about earlier. And there's some real benefits to be had by looking at each of those things. And one of the big ones that is gaining even more traction this year is the Internet of Things, which you heard probably a lot about this morning. And when we talk about the industrial Internet of Things, or things in general, we're talking about assets in the plant, or machines, or products in the field, or devices or physical entities, or any other kind of piece of equipment. So we kind of use all those terms interchangeably. We call it industrial Internet of Things, but it's your product or it's your asset, depending on your point of view. And what we're talking about is connecting this stuff in a better way and then using it, using the information gained to do new and creative things. So Andy talked about the connected car this morning, and this is maybe the basic model of what's going on with that connected car, where you've got the car manufacturer and maybe the car dealer trying to stay in touch with it in one way or another to find out when it needs service, for example. You've got things like maybe I call it the OnStar model, where you can do emergency calls and remote services and some streaming of media and some other entertainment and some navigation. And then, for electric vehicles, you've got to do some kind of management for charging systems for that. So that's a fairly common thing to think about. But we're also seeing a huge growth in things like personal telematics and fleet telematics. And maybe with some controversy, I'd like to have my local garage that I like to service my car instead of the dealer be able to get access to that data sometimes. But I don't know that the manufacturers are necessarily going to like that idea. Insurance companies would love to get more and more of this information so they can find new ways to save you money, really to charge you. With some of the technologies out there, like the dedicated short-range communication stuff, the cars on the road can communicate to each other their status and their position and what's going on with them. So if one of them's braking up ahead of you, it can tell your car, which can start to take some action in response to that. So that's kind of an interesting case where you've got the information on board your car and all the other cars in the vicinity that are cooperating together to help you and everyone really on the road. Some other controversial concepts that come into play here are things like law enforcement telematics or regulatory telematics. So maybe your car won't start if the license tag isn't valid, or maybe there are some other issues that I don't know why, but the police might be looking for that particular car. So those kind of things could come into play, and I'm sure that won't happen without a little bit of controversy. And then, of course, we want to do all this in a way that's secure so that that car doesn't end up falling into the wrong hands. So some of the concepts involved with the industrial Internet of Things involve this notion of a connected asset value network. So when you, or a digital umbilical cord is another way to think about that. So that if you manufacture products that are used in other factories, for example, then you want to keep touch with them. Or in the car example, if you're a Ford, you want to keep touch with all your Fords out there on the road. And that requires that you securely share selected asset information with third parties, manufacturer or other partners. But there's a payoff for you to do that, because you can expect that with more information, these manufacturers will be able to provide you better service, more information about your product, maybe some alerts if something's going wrong, or if they notice some patterns of usage that you hadn't anticipated or that they hadn't when they designed the products. And it also supports innovation, because with that kind of information, manufacturers can continue to tweak their designs, add features that they can see a developing need for in the marketplace. So the idea is to leverage some new sensors as well as data from existing systems to improve operating performance. So the main parts of industrial Internet of Things are the intelligent assets or devices themselves. And that means you have to provide these, someone has to provide these assets with some technology enhancements based from where they are today. So they need to be able to do some computing and some communications at the most basic level. They probably need to be able to gather information from onboard sensors or nearby sensors, and maybe some storage and some other typical computing things. It doesn't have to be a big package, but it has to be able to do that. Maybe probably also run some applications or some agents in order to communicate with the rest of the world. These things are already starting to generate a lot more data than a lot of manufacturers are used to dealing with. So that's another dimension of this that we can't ignore. Then we've got to communicate. So maybe you've got a device that communicates through a SIM card or maybe through a Wi-Fi network. Okay, that's fine if the device has Wi-Fi capability. But then you've got to be able to get it from that first point up into the network and then into your system somehow. So you need sort of some levels of communications. And we could talk about that later today and maybe with our panel as well. Then we've got, on top of that, nothing really happens unless you've got the proper software to do it. So, I used to hear a lot about, well, I can connect all this stuff easily on the plant floor. It was never really true in many cases. And I can send it to your ERP. But ERP and all the other apps didn't really need it. So what's different, though, is that there's growing awareness that, wait, I can solve a new class of problems if I only had some data available. And now the data is coming available. So these two things are coming up together, and we're seeing new initiatives to make the data available and new initiatives to solve the problems. So that's pretty exciting. So we've got software and analytics to make that happen. And then, of course, you need to get people involved in this. So this Intel Edison that Andy talked about this morning is an interesting little SD card form factor device. It's a full computer. And I think it's just important here to represent. I mean, this, you know, in some of their marketing releases, when they talk about this product, they talk about using it in things like sweaters and clothes and things like that. So I don't know if that's a real need for that. But the point is, it's not necessarily a big thing that you have to add, but you do have to add something. Some of the basic concepts that we have here for the Internet of Things involve, like we said, the device with sensors and intelligence and communications protocols and device technologies. There's a concept, which I'll go into in a moment here, about virtual machines, which you'll probably encounter along the way. And then all the other technologies that we've seen on one of my earlier slides and some other places: the cloud, the internet, analytics, carriers and networks, and edge management and security, and there's quite a list of technologies. And then the last bit is the notion of a software-defined machine, so that you can, maybe from your application or from some set of applications, you can maybe pick the sensors that you want to monitor. Okay, that's fine, but you might also do things like change the profile of your car, so that it you know, when my son drives it, it doesn't run like a hot rod. It runs like a granny car or something. I don't know. It's a thought. But he'll probably beat me to the technology anyway and switch it around. So here's the example, again, from the Internet of Things architecture group that I thought did a nice job of introducing the virtual entity concept in this context. So in the physical world, we have, up here on the left, we have you know, the car in the city and the jogger and the temperature and things like that going on. And so you've got two things that are represented to that. So you've got the system, which is the one just next to that, and then below it you've got the notion of exposing some resources as IoT services. So it's the difference between, you know, asking, you know, maybe on your cell phone, to unlock your, you know, to switch this actuator versus unlocking my car. So that's the kind of difference. If you just, I mean, it's a simple concept of virtual entity. It could live maybe at the device, it could live in the cloud, it could live many places depending on how you end up architecting a system. Then we have the notion of the connected asset, which, you know, in this example, so we've got a simple motor and drive and impeller assembly on this pump. And then, you know, you can add, in groups, you can add maybe a bunch of sensors that come with a motor and some sensors that come with the impeller assembly. Maybe you add your own sensors to this whole mix. There are some outputs or some sensors associated with the drive. I mean, this is not a perfect example, but I hope you get the idea that there are some ways that you might be able to take all these things that you might monitor separately and put them together and say, this is a pump. And this is a pump that I'm using for this purpose, and then let it communicate with the rest of the world. But a different model would be you could just leave those groups of sensors disconnected and let them connect independently or maybe in groups back up to the internet. Where now you have to have an application somewhere in the cloud or somewhere in your system that combines them all back together and says, I know these pieces, I recognize them, and that's a pump. So it could be either way, or it could be in both places. These are some of the kinds of questions that you know, start to come to the fore when we start to think about the Internet of Things. And I don't think there's necessarily one right answer for it, but it's interesting that everybody's starting to wrestle with it. This is the project that I referred to, and Andy mentioned it this morning. This project really was running for several years, and they did finish with the help of many of the folks here and some others, putting together a nice reference model and some fairly detailed architecture work. So they're still moving on from that. I won't really spend a lot of time in that, but the notion, though, is that there's some work that's been done. It's pretty thorough. It covers everything from how the information might flow to some of the communications and functions that are required, and so they've done a nice job of laying things out that way. It's a pretty good starting point, if nothing else. So here's the big question. How much will the industrial Internet of Things change plant software and architecture? I mean, we know on the way this works today, sensors and other devices in the plant are wired through control systems, and they're wired through network hierarchies. And there's a way to do things, and it's expensive and time-consuming to do it. Can we foresee a future where that pump will be smart enough to connect to wherever it needs to connect to, or maybe the apps will be smart enough to find that pump when they need it and monitor it? Well, maybe not. Maybe not. But on the other hand, for certain sensors and for certain applications, yeah, that might be a nice way to go. That you can add a lot of information and make things operate a lot more efficiently without necessarily adding the traditional cost of hardwiring and running through control systems and then integrating to get the information back out of there, because that's hard. And we know that manufacturers already know how to do this, and there are a lot of companies out there that are spending a lot of good work actually to kind of harden and make these kind of systems more secure. So the question then becomes, well, if you have systems like that and plans for systems like that in your plant, is there a way to leverage them to start to get some of the benefits for this industrial Internet of Things? And here's just one, just one example is, well, what about this notion of providing selected information back to the vendors of some of my assets? Well, I may have some of the information already, here in my systems, and I've got it because I've got a machine, and I've got some controls interface, and I've got some kind of application where I identify that thing as a pump. This is this such and such pump, and here are the sensors and data points associated with that. And then maybe I've gone to the trouble to build some kind of another interface and share some of that information with my ERP system or with some other systems. Well, a lot of places have something that looks like that for a lot of their equipment, and if you do, then why not just tap in to the right place there and add some cloud-based services to securely share some of that information with those vendors. They'll benefit by it, and you'll benefit by it. Because they can start to do things like monitor their in-service assets, products, and if they start to do a lot of that, then they can start to run some kind of diagnostics or some kind of predictive analytics that you won't be able to as a single user. So they can monitor and analyze and alert you. They can improve their designs, reduce their warranty support costs, and provide maintenance services. And all these things, they benefit the final users of these products. Excuse me. So Andy went through this slide this morning. So in the interest of time, I'm going to just skip through that. We can come back to if there are any other questions. So then, just a couple of final thoughts. We have, with regard to this general space of information-driven production and industrial IoT, there are initiatives underway both in Europe and here in North America. In Europe, we're hearing a lot of talk about something called Industry 4.0, in addition to the Internet of Things architecture stuff and some other things as well. Then the next speaker after me will talk a little bit about a more local US-based, but I don't think strictly limited to the US, piece of work here, which is smart manufacturing. And Jim Wetzel will talk about the Smart Manufacturing Leadership Coalition and what his company is doing as he's involved with that. And the other piece that, a lot of what we hear and a lot of what we think is going to, sooner or later, involve plant software and things like MES or operations management systems and EMI and EAM and things like that. So then our speaker, our final speaker before our panel today will be talking about a massive installation of MES systems across multiple plants that went on pretty much in parallel. So I won't try to tell that story, but it's a pretty good story too. So that's what we got here for today, and thank you very much.